Ground level in Chongqing can sit 22 floors above another road. The reason reshapes how more than 30 million people move. Chongqing does not spread across flat land. It climbs cliffs, bridges two great rivers, and stacks rail lines, roads, homes, and public squares into the same narrow space. That pressure produced an urban machine of rare force. It also packs daily life against concrete, noise, and surging crowds. I used to think the 8-dimensional city label captured its genius. It captures only the spectacle. In this video, we examine how Chongqing bends transport and architecture around brutal terrain. Then ask whether China's wider feats of scale free ordinary life or press harder against it. A night view built to draw crowds can leave almost no room to move. Around Hongya Cave, crowds can press along roughly half a kilometer or more, while the attraction drops about 12 levels from an upper street toward the Jialing River. The descent explains why Chongqing is often read incorrectly at first glance. A doorway that feels like ground level can lead through restaurants, stalls, escalators, and terraces before opening beside a riverside road far below. Hongya Cave turns that vertical puzzle into commerce. The complex follows traditional regional stilt house forms, but its modern burden is moving people across stacked floors. Across the Jialing, illuminated towers and Qiansemen Bridge lock the view into a familiar image. The Yangtze lies beyond the confluence, not directly beneath every central lookout. The lights draw attention, but fame concentrates it. Social media, synchronized illumination, evening food traffic, and a few favored camera positions pull people toward the same edges. This is not simply the density of a vast municipality. It is density squeezed into a handful of pavements, stairs, crossings, and bridge approaches. Behind the panorama, vendors keep counters moving. Cleaners clear the ground, transit staff direct flows, and barrier crews and traffic controllers protect the narrow routes that remain. Their work is the hidden infrastructure of the night. Without it, the same lighting that builds the attraction would overload the streets supporting it. What stands out is the price paid in ordinary comfort: slow steps, compressed space, blocked crossings, and little freedom to choose another path. The skyline remains extraordinary, and the engineering behind these stacked streets is undeniable. Yet vertical access alone does not guarantee a humane night. At Hongya Cave, the city proves it can turn a 12-level cliff into a glowing destination. The packed approaches prove that spectacle can still outrun comfort. A district built for feet now faces a skyline built to command an entire river. Below, the Yangtze runs for roughly 6,300 kilometers. Across the water, a sky bridge about 250 meters long crowns Raffles City, Chongqing. That contrast explains Chongqing better than another tower count. The old quarter brings movement back to the body. Stairs, narrow lanes, shop fronts, courtyards, tiled roofs, and timber details. These streets recall an era when the slopes set the route and working docks set the pace. Goods and labor moved through passages shaped by the mountain, not flattened against it. But this is not one untouched block of antiquity. Surviving or restored details now share the lanes with food vendors, souvenir shops, and staged photo locations. Historical dress adds ceremony and commerce at once. It can keep old forms visible, yet it can also turn the district into a background for consumption. The Yangtze carries a larger burden than the view suggests. Asia's longest river links China's interior with cities downstream, making this old quarter part of a working transport corridor, not simply a scenic edge. Across the water, scale changes hard and fast. At the river confluence, dense towers close the horizon, and Kuixinglou becomes a gateway defined by mass, height, and engineered reach. The crystal links 4 towers high above the complex. It is a remarkable feat, lifting a structure about a quarter of a kilometer through open air. What stands out is the contest for attention. The older district frames the river, but the mega-project increasingly frames the older district. Crowds add pressure. Narrow lanes must absorb vendors, shoppers, costumes, and repeated stops for the same landmark image. The view is magnificent, but success depends on keeping these lanes useful for daily life, not reducing them to viewing decks for engineering spectacle. A city built to defeat mountains became globally famous through a screen small enough to fit in one hand. The original short drew around 30 million views. Reposts across several major countries pushed its estimated combined platform reach towards 600 or 700 million. Those are not verified unique viewers, but they reveal how powerfully Chongqing's stacked streets break ordinary ideas of a city. The label 8D City is internet shorthand, not a planning term. The terrain supplies the real explanation. At the meeting of the Yangtze and Jilin rivers, steep slopes leave little room for a conventional grid. Roads climb, rail lines cross towers. Bridges, entrances, and public spaces occupy elevations that would be separate neighborhoods elsewhere. Doorway can meet street level on one side, while the opposite exit opens many floors above another road. That is more than visual surprise. It is the daily machinery required to move residents, deliveries, buses, and trains through broken ground. Chongqing has been a directly administered municipality since 1997. Its roughly 35 million residents are spread across a vast jurisdiction, not one endless downtown. Urban districts share that territory with smaller cities, towns, and rural counties. The scale is immense, but it is often misunderstood. Fame has a physical price. Viewpoints and transit sites built for movement have become destinations themselves. More visitors bring attention, but they also pack pedestrian routes, load transit entrances, and tighten streets already constrained by rock and water. The same infrastructure that conquers height can concentrate noise and bodies at a few celebrated points. Engineering wins space, then popularity takes some of it back. Hundreds of millions of views prove Chongqing's pull. The harder test is whether its extraordinary cityscape can remain comfortable for the ordinary day. The ground beneath an ordinary public square is also the 22nd floor of the city below. From the upper road, buses, restaurants, pedestrians, and building doors meet on one level. At the exposed side, the land drops roughly 22 floors toward a lower road. This is not a decorative rooftop trick. It is Chongqing's hard answer to steep ridges and scarce level ground. Here, ground level moves with the slope. A normal plaza at one elevation becomes a roof and a high edge at another. Towers and broad podiums lock into roads at several heights. Footbridges, elevators, escalators, and stairs bind those layers into one working city. Lift through a commercial building can serve almost like a public street, carrying people between neighborhoods that sit vertically apart. That shortcut matters because two entrances that look close on a map may demand a long climb or a wide detour. Stacking also separates some vehicles from pedestrians and gives businesses access where the mountain refuses to provide a broad, flat block. The engineering is bold, but the burden does not vanish. It shifts into navigation, maintenance, and the narrow points where layers meet. Residents must read signs in 3 dimensions. Visitors can miss the correct elevation even when the destination appears to be directly ahead. Delivery traffic needs loading access at different heights, while buses and pedestrians compete for limited space around the same entrances. Barriers, lighting, elevators, and clear evacuation routes are not background details. They are what keep this vertical arrangement usable under pressure. When connectors grow crowded, efficiency can turn into compression. Every shortcut becomes another place where ordinary movement must squeeze through. The mountain has been solved at this point. The bottleneck has moved to the lift, stair, curb, and crowded connector. Nine centuries before the vertical spectacle, 2 royal promotions gave Chongqing its name. Nearly 9 centuries ago, Zhao Dun was elevated first to king and then to emperor. Guangzhou was renamed Chongqing, commonly read as double celebration. The meaning carries real weight. It ties the modern city to the Southern Song dynasty and to a specific act of political power. Long before towers occupied these slopes, the ridges gave protection and the rivers carried trade. Geography made this a regional center before reinforced concrete changed its profile. The record reaches further back, through the memory of the Beibi people and names, including Jiangzhou, Yuzhou, and Gongzhou. Each name marks a different administrative age on the same hard terrain. That long sequence matters because Chongqing is often reduced to its latest image: monorails, crowded viewpoints, and illuminated towers on steep ground. The old district preserves a different record. Gates, temples, street patterns, restored buildings, and food traditions show that a city is more than its newest engineering. Yet, preservation carries its own strain. Historical forms must compete with redevelopment, commercial display, and viral images of infrastructure that seize attention in seconds. Double celebration offers a hard test for the city it now names. Progress should add another layer without covering those below. That does not require freezing Chongqing in the past. River commerce, socialist-era construction, and contemporary redevelopment already show a city repeatedly rebuilt around new demands. The harder task is control. New works must carry millions through steep terrain while leaving room for old gates, familiar food, and streets whose scale still fits ordinary life. Double celebration deserves more than a plaque. Old names, gates, and street patterns must remain clear beneath the towers that now define Chongqing. Homes sit above the rails, shops below, and a commuter train vanishes through the middle. At Liziba, Line 2 occupies roughly the 6th through 8th floors, with shops below, homes above, and trains arriving at peak times about every 2 minutes. The spectacle begins with a hard constraint. Chongqing slopes leave little room for straight, level rail, so the route must bend, climb, and share space already claimed by the city. Straddle beam monorail answers that terrain. Rubber-tired trains can take tighter curves and steeper grades than many conventional urban railways. But the engineering challenge does not end when the track reaches the building. The station and tower must coexist without sending the railway's full movement into the homes overhead. Enclosed track sections, resilient supports, rubber tires, and careful maintenance all work to restrain vibration and noise rather than pretend they do not exist. A train may pass in seconds, but for residents, the corridor is a permanent neighbor, active throughout daily service. The famous image hides a bargain. The city gains a direct route through brutal terrain, while private rooms absorb the pressure of proximity. Down below, a practical station has become a stage. A dedicated viewing area fills with visitors using forced perspective, opening their mouths as the approaching train seems to enter. The short service interval keeps feeding that performance. Commuting, tourism, and residential life are compressed into the same narrow slice of concrete. Liziba deserves its reputation. The railway does not avoid the mountain or remove every obstacle. It threads transport through an occupied structure and keeps moving. The unforgettable image lasts seconds. Above the rails, success sounds like an ordinary room. One steel arch carries a city's daily pressure on 2 separate decks. Its main span reaches about 550 meters, crossing the Yangtze with road traffic above and the loop line rail alignment below. That arrangement is Chongqing's answer to a hard physical limit. There is little flat ground for separate bridges, and every approach must squeeze between slopes, towers, neighborhoods, and elevated roads. Opened in 2009, the bridge does more than cross a river. It compresses several transport corridors into one steel frame, reducing the ground more crossings would consume. The upper deck carries vehicles and pedestrians below. Rail shares space with road and service functions, while boats retain a broad navigation channel under the central span. This is engineering at full urban load: commuters, freight, metro trains, wind, and vibration acting on the same structure. The truss drives those forces toward massive supports on both banks. Steel expands and contracts. Wind, vibration, and the combined weight of traffic must be monitored while vehicles and trains keep moving. Spectacle here rests on discipline. A structure this large depends on inspection, adjustment, and maintenance repeated without pause. Yet capacity is not the same as comfort. When traffic thickens at either end, pressure leaves the bridge and enters the streets, ramps, and neighborhoods around it. That is the central contradiction. Stacking movement saves scarce ground, but it also concentrates engines, noise, and delay along one already crowded line through the city. The arch dominates the skyline because it had to dominate distance. The districts beside it receive the traffic it gathers. The span is astonishing, yet when the approaches stay packed, the structure that conquers river and mountain can still leave nearby streets louder, slower, and harder to live with. Centuries-old wooden tower now survives behind a modern wall built to hold back a transformed river. Shibaozhai rises through 12 red stories beside the Yangtze, while the Three Gorges Reservoir has turned its former hillside setting into an island-like landmark. Far from Chongqing's central skyline, this is the Stone Treasure Fortress, a steep rock outcrop wrapped in timber. The pavilion developed during the Qing period as a protected stair-like route toward temple buildings at the summit. Later expansion produced its present 12-story form. Every level negotiates the cliff. Timber frames carry projecting eaves, while narrow stairs, windows, and balconies press human movement into the rock's severe vertical face. This is an older answer to Chongqing's defining problem. Long before monorails and super-tall towers, builders were already forcing circulation upward across unforgiving ground. The river then changed the terms. When reservoir levels rose, engineers enclosed the base with a protective dike, and a suspension bridge became the new line of access. Preservation here cannot mean locking the past in place. Water must be drained, slopes held, timber maintained, and seasonal reservoir shifts watched. Vitter pressure adds another load. 12 tight floors were shaped for a cliff route, not for mass tourism moving through narrow stairs and balconies. Dikes, bridge access, drainage works, and safety controls keep the pavilion standing. Yet modern hardware can crowd the historic form it was built to protect. What stands out is the structure's discipline. It grips the cliff floor by floor with wood, joints, and controlled weight rather than monumental bulk. Modern walls can hold back the reservoir. They cannot replace the intimacy of 12 timber floors gripping rock. About 20 ramps occupy the space where a flat city might build one broad junction. At Huangjuewan, 5 principal levels divide traffic between central Chongqing, nearby districts, expressways, and routes toward the airport. The shape looks excessive until the ground explains it. Steep slopes, existing buildings, and limited space rule out the low, spreading cloverleaf used on open land. So each turning movement must find height instead of width. Roads climb, descend, overlap, and curve around columns while preserving safe gradients. A ramp needs room for vehicles to merge, drainage to clear water, and enough clearance from roads above and below. From above, unrelated routes seem fused into one mass. At road level, lane markings, overhead signs, navigation tools, and early decisions separate that mass into single choices. Those choices carry a cost. A missed exit can force a long detour because barriers and changing elevation leave few places to reverse direction. Beneath the traffic, crews face a second challenge: lighting, pavement joints, retaining walls, protective barriers, and drains must remain sound across several stacked routes. Inspection is difficult because one closure can disturb several connections at once. Access gets squeezed between active lanes, columns, and steep ground. Huangjuewan is not confusing by accident. Its complexity records a city forcing more traffic through land that cannot spread. But solving the route does not remove the burden. It concentrates engines, signs, concrete, and constant maintenance inside the same urban volume. That is why the interchange is both extraordinary and unsettling. It masters the mountain by stacking roads higher, yet each new layer presses harder on clarity, quiet, and human scale. Those ramps keep Chongqing moving. If more pressure brings more layers, the roads may work while daily life is left with less quiet and less room to breathe. Chongqing is only the opening case. In Beijing, an ancient ritual form carries more than 100 floors into the sky. China's Zun rises about 530 meters over the central business district, making CITIC Tower the capital's tallest building and its dominant office landmark. CIT's base and crown widen around a narrow middle, recalling a zun, an ancient Chinese wine vessel. The symbol also complicates the frame. At this height, wind does not merely strike the facade, it pushes the whole building to sway, while immense loads drive downward into deep foundations. Beijing adds another demand: strict resistance to seismic movement. A stiff central core, perimeter columns, bracing, and outrigger structures make the tower act as one body rather than a loose stack. Movement inside creates its own machine. High-speed lifts carry daily traffic through extreme vertical distances, while mechanical zones divide and support the climb. Refuge areas, separated compartments, and pressure-controlled stairs prepare for disruption. In a tower of more than 100 floors, safety depends on breaking one immense height into protected sections. Completed in the late 2010s, China Zun was designed to command the surrounding business district. One private office tower now fixes the horizon for a vast part of the capital. That visual order comes with physical costs. A super tall building casts a long shadow, demands major energy, and concentrates security, maintenance, and movement inside one narrow footprint. Height transfers pressure downward. Ground, lifts, stairs, utilities, and public space must all absorb the consequences of the crown above. China Zun is powerful because every line serves scale, from deep foundations to the widened crown. But when one tower dominates the civic horizon, engineering no longer just solves space, it decides how the city must live beneath it. Steel seems to tangle around Beijing's Olympic Stadium. Every line is held by exact calculation. Around 42,000 tons of steel surround a seating bowl that held about 90,000 spectators during the 2008 Summer Olympics. Beijing National Stadium was designed by Herzog and de Meuron with Chinese architectural partners, and artistic consultation from Ai Weiwei. The steel members made the bird's nest nickname unavoidable. Yet the lattice is not decoration laid over a conventional arena. Each major member carries force, continues a structural line, or helps conceal stairs, roof edges, and surfaces. That fusion gave the stadium its authority. Engineering did not sit behind the public image. Engineering became the image. But Olympic scale creates a hard obligation after the crowds disperse. A building made for exceptional attendance must still earn the labor and energy required to keep it ready. Temporary seating came out after the games, reducing the original capacity. The permanent steel did not become lighter, simpler, or easier to maintain. Corrosion control never ends. Inspections must trace the load paths, utilities must run, and security and crowd plans must adapt to each new event. This is where reuse matters more than reputation. The stadium continued with sport, entertainment, and tourism, rather than freezing as a single Olympic monument. In 2022, it again carried opening and closing ceremonies, this time for the Winter Olympics and Paralympics. Few venues have stood at the center of both Summer and Winter Games. What stands out is the bargain behind the spectacle. The steel can dominate space, but its public value depends on steady programming, safe access, and useful life between global events. Between global events, the case for 42,000 tons of steel is made through useful programs, safe access, and life around the stadium. A monumental theater beside Tiananmen Square keeps much of its physical mass out of sight. Opened in 2007, the National Center for the Performing Arts presents a titanium and glass ellipsoid above water while much of the complex extends underground. French architect Paul Andreu placed it near the Great Hall of the People, where any large building can press against the historic skyline of central Beijing. Its common nickname, the giant egg, captures the outline but misses the harder decision. The building achieves national scale without forcing its full bulk into the skyline. Entry begins without a conventional door cut into the shell. The approach runs through a long subterranean passage beneath the artificial lake, with water visible overhead. That route slows the transfer from city traffic to performance. Distance does work that a louder facade might otherwise try to do. Inside opera, concert, theater, and smaller events occupy separate venues. They may share one civic address, but they cannot share one acoustic or backstage plan. Each hall needs its own sound shaping, rehearsal areas, loading access, and circulation for performers, staff, and audiences. Outside noise must be kept apart from the work on stage. The quiet exterior therefore rests on hard, continuous labor. Waterproofing holds back the lake, mechanical equipment serves the halls, security manages entry, and schedules keep competing events apart. Around the shell, water creates reflection and physical distance. Instead of another crowded line of facades, open space becomes part of the architecture, not leftover ground. What stands out is the restraint. Monumentality comes from controlled geometry and empty space, not height, exposed structure, or aggressive lighting. That restraint protects human scale without shrinking civic ambition. Enormous technical force is used to lower pressure on daily life. Readers become background figures inside Tianjin's most famous room. Tianjin Binhai Library opened in 2017 with a towering atrium, yet many of its highest book-filled bands are printed images, not reachable shelves. At the center sits a spherical auditorium known as the Eye. The facade frames it like an iris, turning the building itself into a public image. Around it, white terraces work as stairs, seats, circulation routes, and places to read. One surface carries several jobs, and that is serious engineering. But the room also attracts people who come mainly to photograph it. Visitors climb, pause, and meet around the spatial illusion, while staff keep the floor moving. The building splits image from service. Much of the usable collection sits in conventional reading rooms beyond the atrium. That is where the library must do its less visible work. Catalogs, quiet study, children's services, and accessible routes. None of those tasks becomes easier because the atrium went viral. The terraces add another burden. Their pale surfaces invite constant movement, but they also demand cleaning, crowd control, and careful safety management. This is the central pressure inside Binhai. Architecture designed to draw people toward knowledge can also draw attention away from reading. The spectacle is not empty. It gives a civic building scale, makes circulation legible, and turns a cultural district into a recognizable public landmark. Yet the measure of a library is not the height of its illusion. It is whether a child, a student, or an older reader can still find quiet, access, and time. The way I see it, Binhai is extraordinary, precisely because its flaw is so visible. When readers become background figures, monumental design has taken too much of the room. A monumental opera house can rise from a wetland without making the ground feel crowded. Completed in the mid-2010s on an island beside the Songhua River, Harbin Opera House contains 2 performance spaces inside one broad, low envelope. Mad architects did not place a generic glass box in northern China. White aluminum bends around the halls to recall snow shaped by Harbin's wind. That smooth outline hides hard work. A large theater, a smaller hall, rehearsal rooms, loading areas, and backstage routes must operate without crossing at the wrong moments. Inside the main auditorium, dark timber and flowing balconies bring warmth against the pale exterior. Acoustic surfaces then control what architecture alone cannot: live sound. Outside, the building gives part of its mass back to the public. Broad steps and exterior paths let people climb across sections of it without holding a ticket. That choice matters. A major cultural building does not end at its doors. It opens long views across the wetlands and keeps public movement outside the ticketed halls. Harbin avoids the cramped force of many landmarks by spreading its size across the ground rather than pressing it into one hard block. Northern weather is the real test. Snow loads, ice, wind, freeze-thaw cycles, and large seasonal temperature swings all pull at the clean exterior. Drainage must carry meltwater away. Sealed joints must resist repeated expansion, while non-slip routes and snow clearance keep the public paths usable. The pale skin also demands inspection, maintenance, and energy. Smooth architecture in this climate survives only through continuing labor. That labor protects more than an image. It protects performances, backstage work, public access, and the open ground that prevents the landmark from overwhelming daily life. Its greatest achievement is simple: broad steps, open ground, and room for ordinary life. At more than half a kilometer high, a skyscraper cannot ignore the wind. Its entire shape must answer it. Shanghai Tower rises about 630 meters over Lujiazui, carrying nearly 130 floors above ground. Its outer glass skin turns roughly 120 degrees as it climbs, while the shaft narrows toward the top. That twist reduces exposure to wind compared with a plain rectangular tower. Less force on the frame means lower structural demand. This is not styling added after engineering. The silhouette comes directly from the pressure of building at extreme height. Below, Jinmao Tower and Shanghai World Financial Center complete a 3-building record of Lujiazui's rise. Each captures a different stage of vertical ambition. Inside, the scale is broken into stacked zones: offices, hotel rooms, shops, observation areas, mechanical floors, and planted sky lobbies. Second facade sits behind the outer skin. Between them, tall atriums temper the climate and create shared interior space. High-speed elevators cross distances that would form a substantial journey on the ground. The frame is tuned to limit sway. The machinery makes 630 meters usable, not merely visible. That is the tower's real engineering achievement. But height concentrates pressure below. Dense towers bring deep shade, heavy transit demand, large energy needs, and streets measured against immense walls. What stands out is the split between the observation level and the pavement. From above, density looks controlled. At ground level, it becomes daily load. The tower organizes offices, hotel rooms, shops, and shared spaces inside one frame. The pavement outside must absorb every arrival. Sit's twist is astonishing because it masters wind and height. The surrounding density is sobering because ordinary human scale can almost disappear beneath it. Jinji Lake opens a broad horizon until one giant arch nearly occupies it. The Gate of the Orient rises about 300 meters, with two separate towers joining near the top. That connection is not a decorative bridge. Large transfer structures must carry weight across the opening and steady both legs against wind. Each side still needs its own core, elevators, services, and emergency routes. The apparent simplicity hides two complete high-rises under one roofline. Offices, homes, hotel rooms, shops, and leisure space fill the structure. This is a mixed-use district compressed into a single skyline marker. Scale does most of the work. Across the lake, the arch reads as one object rather than a collection of separate buildings. At night, illuminated edges make that outline even harder to ignore. The waterfront gains an instant identity, but other structures lose room to be noticed. What stands out is the imbalance. Engineering gives the district a clear center, yet the same mass can dominate every neighboring line. The building stands in Suzhou Industrial Park, east of the historic center. Broad roads and large parcels set a far larger scale. Historic Suzhou is known for canals, gardens, narrow streets, and lower roofs. Here, roads and construction serve a modern business district. That contrast matters because both places carry Suzhou's name. One is built around close distances. The other announces expansion through a 300-meter frame. Public reaction adds another limit to monumental design. The arch has drawn comparisons to a pair of trousers, a nickname no structural calculation can prevent. Designers can control load paths, elevator shafts, and wind resistance. They cannot fully control what citizens decide a landmark means. The Gate of the Orient succeeds as a feat of joined towers. Yet beside Jinji Lake, its enormous frame leaves too little skyline beyond itself. A tower built to carry signals now competes with an entire city for attention. Rising roughly 600 meters beside the Pearl River, Canton Tower was completed in time to become a visual marker for the 2010 Asian Games. Sit's shape begins with two offset ellipses, joined by a diagonal steel lattice. As the frames rotate against each other, the tower tightens into a narrow waist, then opens again. This is not styling laid over a mast. The exposed grid is the mast, carrying the floors while bracing the tower against wind. Engineering and image are locked together. The same frame that holds the tower upright also gives its programmable lighting a vast three-dimensional surface. Within that frame, enclosed floors carry broadcasting equipment, observation decks, restaurants, exhibitions, and visitor attractions. Infrastructure has been packed inside spectacle. Near the roof, glass cars circle the perimeter in the bubble tram, turning extreme height into a commercial ride. The building does not merely occupy the skyline, it sells access to it. That experience loads the tower with daily physical demands. Fast lifts, lightning protection, wind monitoring, facade access, mechanical equipment, and crowd control must all work behind the display. After dark, LEDs trace the steel mesh and change color for events. A communications tower becomes a moving public sign on Guangzhou's river axis. What stands out is the double achievement. Wind is resisted, signals are carried, and a city gains an unmistakable emblem. But the same intensity that creates identity also keeps demanding attention. The effect reaches beyond electricity use. Changing light, visitor queue, lift traffic, and late-night crowds turn one vertical landmark into continuous urban pressure. At night, the exposed engineering is mesmerizing, yet 600 meters of changing light leaves the Pearl River waterfront without a quiet visual interval. No road reaches Rudong's turbines. Every foundation, cable, and repair begins at sea. Off Rudong, shallow water and intertidal mud replace firm land. Specialized vessels must build each turbine from the seabed upward. The work starts below sight. Survey crews read the bottom before foundations are fixed into soft ground that must resist waves and currents. Jack-up platforms lift clear of the water to gain stability. Cranes then stack tower sections, nacelles and blades, high above a moving surface. The turbines are only the visible edge. Array cables join them to offshore substations, where voltage rises before electricity moves toward Jiangsu's mainland grid. Some Rudong projects have tested advanced offshore transmission to cut losses over distance. Clean generation matters less when power is lost before landfall. Construction ends, but pressure does not. Salt attacks steel, monsoon weather blocks access, typhoons load the towers, and currents keep testing the foundations. An onshore turbine can be reached by road. Offshore, technicians need a safe weather window, a service vessel, and the right parts before the route closes. Remote sensors carry part of that burden. They flag heat, vibration, and wear early, while forecasts decide whether crews can reach the platform. What stands out is the bargain inside the scale. Open water remains between turbines, yet foundations, buried cables, safety zones, and vessel lanes can press fishing grounds. The pressure reaches beyond boats. Construction can alter seabed habitat, while migratory birds cross a seascape now occupied by tall, moving machinery. Rudong explains Chongqing's lights from the far side of China. Coastal generation and inland cities share one chain, though most of its labor and strain remain unseen. Rudong turns brutal marine conditions into power. From Chongqing's crowded slopes to these occupied waters, engineering earns its grandeur only by leaving people, livelihoods, and habitats room. Stone, glass, corners, and shadow meet pedestrians before the music does. Opened beside the Pearl River in 2010, Guangzhou Opera House places two irregular volumes at the center of Zhejiang New Town's cultural district. Zaha Hadid architects rejected the balanced face of a conventional civic hall, granite, glass, concrete, and exposed structural lines fold into sharp planes, making identity impossible to miss. The larger volume contains the main opera auditorium. The smaller one supports a multi-purpose performance space and related functions, so the split form also divides the building's work. Public routes pass between and around both structures, tying them to the riverfront, library, museum, plazas, and nearby business towers. The Opera House is not an isolated object. It controls a key pedestrian passage through the district. Inside, the priorities change. Flowing balconies and carefully modeled surfaces distribute sound and protect sight lines, placing the audience and performance at the center of the engineering. That interior precision matters because an opera hall cannot succeed on shape alone. Every seat must receive sound clearly, and every balcony must serve the stage rather than the facade. Outside, the cost of character returns. Each joint edge, drainage path, and cladding transition creates another point that must be inspected and repaired. Guangzhou's humid, rainy climate keeps pressing water against those complex surfaces. Geometry that looks decisive from a distance becomes a maintenance burden at close range. Exterior command gives way to interior care. The hall bends itself around listeners, while the outer shell holds pedestrians at a harder distance. The building refuses to disappear into the business skyline. Its sharp surfaces also show how a hall can care for listeners while holding everyday public life at a distance. Commuters, deliveries, and security lines gather on the narrow plot below a tower nearly 600 meters high. Ping and Finance Center rises through roughly 115 above-ground floors in Shenzhen's Fuxian Business District, close to major metro and rail services. That concentration captures Shenzhen's transformation. In only a few decades, a much smaller border city became a global center for technology and finance. On a narrow plot, the building's functions had only one direction, upward. Offices, conference halls, retail links, and a public observation level were stacked into one immense column. Height magnifies every force. The tapered profile cuts exposed area as the building climbs, reducing the wind's grip. Inside, megacolumns lock into a reinforced core. Belt trusses and outriggers transfer immense loads and stiffen the narrow frame. That strength must hold through the typhoon conditions of southern China, while stainless steel facade elements endure the humid coastal air. Even movement becomes heavy engineering. Express lifts run to transfer zones, avoiding the waste of sending every car from the street to the top. Mechanical and refuge floors compartmentalize the climb, so safety, services, and evacuation can be managed in sections. But the pressure does not stop at the facade. Daily routines converge below in commuter surges, delivery traffic, security boundaries, and crowded entrances. The way I see it, the achievement is undeniable, yet the pedestrian can become the smallest element in the plan. This is the test facing every megacity that builds past natural limits. Technical power matters only if it protects the ordinary day it was meant to improve. At street level, nearly 600 meters comes down to room, time, and ease. Building can contain so much urban life that the city outside begins to feel optional. New Century Global Center stretches roughly 500 meters long, 400 meters wide, and 100 meters high, enclosing nearly 2 million square meters. Chengdu's answer to scale is not a needle in the skyline, it is volume, spread across distances comparable to a neighborhood. Under the wave-like roof sit shopping streets, offices, hotels, restaurants, cinemas, conference facilities, an ice rink, and a vast indoor water park. An artificial beach, digital scenery, and an immense illuminated screen manufacture an outdoor horizon inside controlled air. Work, meals, accommodation, and recreation can all happen without frequent return to the surrounding streets. Convenience becomes enclosure. Moving those crowds requires infrastructure on the scale of a district. Multiple entrances feed internal roads, escalator banks, service corridors, loading areas, and clearly marked routes. The distances can disorient. Every junction must direct people clearly, while protected zones and access routes keep the interior manageable under pressure. Above them, the roof and mechanical equipment fight several loads at once: daylight, smoke control, humidity, ventilation, temperature, and water treatment. None of this vast interior runs by itself. It depends on energy constant maintenance and commercial activity strong enough to keep enormous spaces useful. What stands out is the bargain hidden inside the spectacle. Shelter from weather and traffic comes with dependence on machines, signs, retail schedules, and managed attractions. The complex can remove friction from daily life, but it can also remove open air, street crossings, and the choice to step outside between tasks. New Century Global Center proves that engineering can fit a district beneath one roof. Its limit arrives when convenience packs people and routines so tightly that no breathing room remains. A renewable power station can cover so much dry land that it no longer resembles a single station. Gansu Wind Farm is a group of projects tied to the Jiuquan Wind Power Base, spread across the Hexi Corridor and Gobi Edge country. Open terrain and pressure differences provide useful onshore wind, but this resource lies far from the eastern industrial and urban regions with much greater electricity demand. Each rotor begins the same chain. Aerodynamic blades turn equipment inside the nacelle, a generator makes current, and collection cables feed substations. From there, High-voltage lines must carry the output into the wider grid. A turbine is only the first machine in a much longer chain. Distance is the central difficulty. Gansu's wind output can exceed local demand, so transmission capacity and grid scheduling decide how much clean generation is used. Earlier projects faced curtailment when output exceeded the network's ability to absorb or export it. Stronger long-distance links and tighter coordination became as important as more turbines. That is the hidden argument in this landscape. Building generators is not enough. Power matters only when the grid can move it as it arrives. The work is physical and relentless. Technicians follow access roads to inspect blades, gearboxes, converters, towers, and cables under dust, temperature extremes, and icing. Renewable does not mean weightless. Foundations grip the ground, roads divide the open terrain, substations and power lines extend the footprint beyond each tower. Motion without fuel brings hope. Repetition across such a wide space brings unease. Scale relieves one pressure by placing another on land and labor. Gansu shows what China's energy shift demands, not isolated turbines, but territory, maintenance, transmission, and discipline. The power is cleaner, the physical claim on space remains immense. Beyond the landmarks, the larger network comes into view. At Xining, rail must prepare bodies and machines for thinner air. Xining stands roughly 2,300 meters above sea level, where eastern rail networks meet routes climbing west toward Lhasa. Rebuilt as a major hub in the 2010s, it links conventional and high-speed services toward Lanzhou and Xinjiang, while feeding the Qinghai-Tibet Railway. That makes the city more than a stop. It is a transfer and preparation point between lower eastern networks and the much higher plateau. Trains continuing across the plateau use equipment built for altitude, supplemental oxygen, sealed or pressure-managed passenger spaces, and strict operating routines. The mountain is not overcome once. Its pressure returns in every carriage, timetable, and traveler, adjusting to the height. Inside the terminal, ticket checks, security screens, waiting halls, platform gates, luggage, food, and cleaning crews break a dense crowd into timed departures. None of that order is automatic. Workers must turn each arriving train around while passengers carry bags, watch clocks, and search for the correct gate. Holiday periods tighten the strain. Workers, students, families, and tourists converge at once, turning regional connection into queues, delay, and physical fatigue. What stands out is the double meaning of the crowd. It proves that distant regions are connected, but also shows the cost of that reach. Outside, buses, taxis, cars, and local transit must absorb each train at once. A late release from the platforms pushes pressure straight into the streets. Xining's strength lies in making distance workable. Yet the same concentration produces waiting, noise, altitude strain, and journeys that feel longer than the map suggests. Sees Xining's connection as valuable only when its human load is protected. Otherwise, rail conquers distance, while comfort is left on the platform. The most audacious part of this sea crossing is the section that disappears beneath the water. Across roughly 55 kilometers, the Hong Kong-Zhuhai-Macau link combines bridges, cable-stayed spans, 2 artificial islands, and an undersea tunnel nearly 7 kilometers long. Opened in 2018, it is not one uninterrupted bridge. It is a chain of structures built to negotiate open sea, air routes, and ship traffic. The tunnel carries the road below major shipping lanes. Traffic descends on one artificial island, crosses beneath the water, then rises on the other. That descent solves 2 constraints at once. Ships retain clear passage, and nearby aviation does not face a high bridge planted across its operating space. Construction had to hold alignment against tides, soft seabed, saltwater corrosion, typhoons, and busy marine lanes. Scale here is not decoration, it is the price of control. The road also crosses legal boundaries. 3 jurisdictions bring separate border checks, customs halls, permits, and operating rules into one journey. Even the side of the road changes. Mainland traffic runs on the right, while Hong Kong and Macau run on the left. That is why shuttle buses and authorized vehicles carry so much of the movement. Concrete alone cannot erase an administrative border. The shorter route serves selected journeys across the Pearl River Delta, but its footprint reaches far beyond drivers. Fisheries and coastal habitats share the same water. There are also concerns for the Delta's Chinese white dolphins. Engineering can command a route, but it cannot treat the sea as empty space. The commitment is as long as the crossing. Every kilometer multiplies inspection, corrosion control, traffic management, and exposure to severe weather. The achievement is undeniable. So is the experience of being processed as a load between checkpoints. Highway built to erase a mountain detour must first hang over a void deeper than most skyscrapers are tall. The Baipanjiang Bridge carries the G56 expressway nearly 600 meters above the river, across a main span of more than 700 meters. When it opened in 2016, it was the world's highest bridge measured by deck height. That record matters because the bridge does not merely rise above terrain. It replaces roads that had to descend into the canyon, cross low, then climb out again. On opposite rims, towers take the load. Fan-shaped cables hold deck sections where scaffolding from the valley floor would have been impractical. Construction crews worked from steep slopes and joined deck sections hundreds of meters above the Baipan River. Every connection had to preserve alignment while the gorge pushed wind across the unfinished deck. This is how engineering compresses geography. Long mountain detours become a brief expressway crossing for passengers and freight. Yet the short crossing hides a permanent burden. Height turns fog, crosswinds, drainage, pavement wear, and emergency access into daily operating concerns. Cables still need inspection. Water must leave the deck, and the pavement must remain sound. Delayed inspection or blocked drain does not make the bridge less magnificent. It shows that magnificence depends on routine labor long after opening day. What stands out is the tension between speed and exposure. The bridge overcomes the canyon as a route, but it never removes the canyon as a force. That same bargain runs through China's mountain building, including Chongqing. Harder ground demands larger works, and larger works press closer to ordinary life. Baipanjiang is extraordinary because it saves time at regional scale. It is unsettling because that advantage rests nearly 600 meters above the river, maintained one cable, joint, and drain at a time. Shanghai pushed a major part of its port out to sea because the water closer to the city could not easily receive its largest container ships. Yangshan Deep Water Port occupies islands in Hangzhou Bay, connected to the mainland by the Donghai Bridge, more than 30 kilometers long. Its first phases opened in the 2000s, moving terminal capacity into deeper water beyond the shallower, sediment-influenced Yangtze estuary. This is not a storage yard. It is a timed transfer machine, built to keep ships, cranes, vehicles, customs, and inland distribution moving in sequence. A crane lifts each container from a ship. Terminal vehicles carry it to a numbered stack before another truck, feeder vessel, or rail connection takes it onward. In highly automated areas, remotely controlled cranes and guided vehicles remove some driving tasks. They do not remove people from the port. Planners assign berths. Staff monitor software, secure cargo, inspect machinery, and handle the exceptions that no timetable can eliminate. Maintenance crews face salt every day. Automation still depends on machinery that corrosion steadily weakens. The port also obeys clocks it cannot fully control, shipping schedules, tides, wind limits, customs procedures, and truck arrivals across one long bridge. Typhoon, fog bank, equipment fault, or delayed vessel can push disruption far inland. Warehouses wait, factory inventories tighten. The container fields form a dense temporary map of global trade, revealing how much weight a megacity shifts to keep warehouses supplied and factories working. Speed at the quay creates pressure elsewhere. Disruption can spread beyond the island through depots, roads, warehouses, and factories. Yangshan operates with immense force, yet its dense stacks expose the heavy side of supercity life. Comfort inland depends on relentless movement offshore. Here, engineering changes not a skyline, but a river, a concrete arch nearly 300 meters high, with its main machinery buried inside the canyon. At Baihitan, 16 underground generating units deliver 1 gigawatt each, a total installed capacity of 16 gigawatts. The dam spans the Jinsha River between Sichuan and Yunnan, where a narrow gorge supplies the rock shoulders needed to brace a high arch. Concrete pushes the water's force sideways into those canyon walls. Stored water enters large intakes, drops through penstocks, spins turbines, and returns to the river below. Elevation becomes rotation. Rotation becomes current. That current does not remain in nearby mountain communities. Long-distance transmission carries it toward major demand centers, making the canyon part of a wider power network. The visible curve is only the front of the project. Underground caverns hold turbines and generators. Spillways manage high flows, while cooling and monitoring equipment guard the machinery. Engineers track deformation, seepage, sediment, and reservoir levels. Their work continues because the pressure changes with every rise and release of water. What stands out is not concrete alone, but the discipline required to keep 16 enormous units working beneath a river held against rock. Hydropower can deliver immense volumes of low-carbon electricity and help balance the grid. Baihetan turns one severe landscape into flexible power for distant demand centers. Yet filling a reservoir at this scale changes settlements, roads, habitats, fish movement, and the river's seasonal behavior. The gain is vast, but the intervention is permanent. The precision commands respect. The scale creates unease. Every controlled megawatt rests on changes that cannot simply be packed away. Electricity leaves the canyon. Altered settlements, habitats, and river rhythms remain. Chongqing proves that brutal terrain can be overcome. Steel, concrete, rail, and human effort hold a vast city together where flat ground barely exists. That achievement deserves respect, but sheer size does not justify itself. The way I see it, the true test begins after the skyline is built. A bridge must shorten strain, not merely dominate a canyon. A tower must support work without reducing people to background figures. Clean power must cut pollution without turning every open horizon into an industrial field. And Chongqing's famous layers must still leave room for quiet streets. Old structures, and ordinary movement. China's great works show the power of this age. Their deeper legacy will depend on whether human comfort remains part of the engineering brief. If engineering is judged by the life it creates, keep following this series as we examine where monumental scale protects daily life and where it begins to press too hard.